Okay, I left directions that the sub was supposed to check your homework, Mike, because you were the only one here yesterday. But just go ahead and keep your homework, and Monday we'll go through both 8-7 day 1 and day 2 homework, especially since Lucas wasn't here yesterday either. Um, so just go ahead and keep your homework, and on Monday we'll go through it all. And so I didn't leave a paper for the sub to mark you for your homework, and so just ignore those directions on the sub plans. But what I do want you to do, if the sub could please pass out the notes that I left for you so we can go over how to solve these equations, and hopefully we can get through these fairly quickly, and then you can work on your homework. But the last part of talking about natural logs and the exponential function is solving these equations, because we want to be able to solve equations, which is the last section in this chapter, um, using some applications and stuff. So these are just some rules I wanted to remind you of. Remember, if you have the same base with an exponent, if those are the same, you can just set the exponents equal to each other. And if you have a log with the same base of x equals log to the same base of y, then again you can just say x equals y. Remember that e is a number just like 2 is a number, it's just an irrational number, and ln is just a special logarithm. So those same rules apply, so I just kind of rewrote those properties using e and using ln. So if you could say e to the x equals e to the y, then we can set those equal to each other, and ln of x equals ln of y if x equals y. And then I just reminder for any equation, what you do to one side of the equation, you must do to the other. So if you square both sides, you add 7 to both sides. We can also do weird stuff like eing both sides and stuff like that. So remember that e and ln are inverses, so you can undo one by doing the other. So if you wanted to get rid of ln, you could e both sides, or if you take the e of ln of x, e and ln cancel each other out, and you just get x back. Same thing with ln of e to the x, they cancel each other back, and you just get x back. So that's a very important thing as we go through these. If you get stuck today on how to solve a problem, my advice is to come back to this page first and then to look at the other examples that we've done. Okay, so I just have a bunch of different examples for you. So here's my little word of advice as we're solving these. It says solve round to the nearest 10,000th, which is 4 decimal places. Usually you want to try to get e or ln by itself on one side. Then you want to try to undo it using the inverse if possible. Use the properties maybe. Solve. Check your answers, because remember you can't take the ln of a negative number. But like this one, you want to get x by itself. So step 1, let's just undo what's around it. So to undo adding 4, I'm going to subtract 4. To undo multiplying by 3, I'm going to divide by 3. Right? That's not really anything new. The new part is, how do I get rid of e? Just like to get rid of a square root, we square both sides. To get rid of addition, we subtract. We do the inverse. Well, the inverse of e is ln. So to get rid of e, I'm going to ln both sides, because I have to keep it balanced. So if I ln this side, then I also have to ln the other side. And really, why does this work? Well, we could bring this out front using our property. I usually don't. I just say ln of e cancels each other out, and I'm left with negative 2x equals ln of 2. So to get rid of e, we're going to ln both sides. And then to solve that, I'm going to divide by negative 2. And remember, just like before, I want both answers. I want the exact answer, which would be this. And then I want the answer that you would get if you type that in your calculator. To the nearest 10,000th, which means 4 decimal places. Remember, you have to close that parenthesis. So ln of 2 parenthesis divided by negative 2, you should get negative 0.3466. I want to see both of those answers. Just like with log equations, they can set these up a lot of different ways, so I just want to try to give you as many examples as I can here. Number 2 here is pretty much just like the one I just did, so why don't you go ahead and get a head start on it and see if you can get the answer, and then I'll do it and we'll compare answers. So I'll be quiet for a minute. Alright, let me see what I get here. Right, again, step 1 and step 2 are just kind of get the E by itself. And then we're going to ln both sides, so I tend to kind of like squish it in like this. And ln of E is just 1. You can bring that out front, so we get negative 2x equals ln of 5. Divide by negative 2, and that would be my exact answer. And negative 0.0, nope, sorry, that's an 8. 8047 is the answer I got when I typed that in my calculator. All right, so E, get it by itself, ln both sides. So what about this one? If we see one like this, there's a couple ways you could solve this problem. But when I see an E, I know I'm going to ln both sides to undo it. When I see an ln, I know I'm going to E both sides. But again, just like with E, you want to get it by itself. With ln, we want to get it by itself. So could I divide both sides by 2 here? Yes. And I would get ln of 5x equals 3. And then to undo ln, we want to E both sides. So I'm going to put an E here, and I'm going to put an E here. Plus, it's just fun to say you're going to E both sides of an equation. And if you have E to the ln of something, it just gives you that something back, just like the square root, and you square it. So I'm going to get 5x equals E to the 3rd power. On my calculators, when you type E, which is the second of ln, it automatically gives you the power. So you always have E to the something. And now I just want to solve that for x, so I'm going to divide by 5, and I'm going to get x equals E to the 3rd divided by 5, which I can do on my calculator and get that to be about 4.0171. Okay, what else we got? Inequalities, we're going to treat the same way. We have some options on this. You might say, why don't I just E both sides first, which we could, but then we're going to have to square root, which is going to get a little ugly. This is where I think the properties come in handy, because remember, we have that property that if we have an exponent out here, we can bring it out front. So we could write this as 2 ln of 3x plus 1 is greater than 8. And now it kind of looks like the one we just did, where we can divide by 2, and we get ln of 3x plus 1 is greater than 4. And now, just like the last problem, to get rid of ln, I'm going to E both sides to cancel that out and get 3x plus 1 is greater than E to the 4th. And now I just have to get x by itself. So I'm going to subtract 1, divide by 3. So I'm going to get 3x is greater than e to the fourth minus 1, divide by 3, and get x is greater than e to the fourth minus 1, all divided by 3. That's the exact answer. Now if I'm going to type this in my calculator, e to the fourth minus 1, either hit enter or put that in parentheses, and then divide that by 3. I think you should get, that's the same as saying x is greater than 17.8661. There are some really good examples in your book, so if you get stuck on this, please look in your book. We have these calculus boys in here that should be able to help you a little bit maybe, even though they say they don't remember them. They probably could help you. One more thing here. I'm almost done. We talked about that interest formula before where it was compounded n times a year. We also have this formula called continuously compounded interest, and that means interest is compounded continuously. So again, this is a formula. You need to know what to plug in. It says A is the amount in the account after T years, P is the principal amount invested, and R is the annual interest rate. And E is the number E that you would use your calculator on. So it says, suppose you deposit $700 into an account paying 3% annual interest, compounded continuously. So when you see compounded continuously, that's what tells you to use this formula as opposed to the other interest formula that we did a few sections ago. What is the balance after 8 years? So we just have to plug stuff in. We want to know what is the new balance. P is the amount we started with, so that's $700. E to the R is the interest rate, but remember we're not going to plug 3 in here, 3%. It's like 0.03 times the number of years, which is 8. Put that in parentheses or you're going to get the wrong answer. And so then this becomes a calculator question. So 700 times e to the 0.03 times 8. Put that 0.03 times 8 in parentheses together. And that would be $889. And we're talking about money here, so round to the nearest cent. $889.87 would be the balance after 8 years. Okay? So that's the easy part when we can just plug in the numbers. What if they ask you to solve for it? So that's what number 6 says. Suppose you deposit $700 into an account paying 3% annual interest compounded continuously. So when I see compounded continuously, I know I'm using PERT. That's what we always called it when I was in school. A equals PE to the RT. How long will it take for the balance in your account to reach at least $1,200? How long? That means I'm looking for time here. So it's not going to be as easy. So let's figure out what we have. How much am I starting with? My principal is $700. My interest rate is 0.03 again. But I don't know my time, right? Instead, I know what I want it to equal. So my A is my new amount, which is $1,200. So now that we know how to solve these equations, they can ask us to solve for time or solve for interest rate. So you got to know the formula, know what to plug in, and then solve it, which means we need to get E by itself. So I'm going to divide by 700. And I'm going to get 12 over 7 equals E, and I'm just going to write that as 0.03t. And just like we did before, when we see E, what are we going to do? To undo E, we're going to ln both sides. So I'm going to get that the ln of 12 over 7, this side, the ln of E is going to cancel out, and I'm going to get 0.03t. I'm going to divide by 0.03, and I'm looking for time, right? So let's see here. ln of 12 divided by 7, put that in parentheses, divided by 0.03, and I get 17.9 7 years. Almost 18 years before that deposit would equal $1,200. Okay? Here's your homework. This is 8-7 day 2. Tomorrow you're going to have a worksheet over this, and then Monday we will turn in the worksheet and we will go over these homework problems. Okay? Okay.